morning, gentlemen. This is Prakash from Managing Director of Bharat Energy Storage Technology. Am I audible, please?
Yes.
You are very well audible. Please go ahead.
Yeah. Actually, the most of the matter relating to different technologies that are there currently being used and moving forward, Mr. Sen has really dealt them at length, and I'm sure a lot of questions probably have been addressed there. What I would probably get into that is understand what exactly is this energy storage thing for the general understanding of our audience, then where we go forward and so on. Basically, this energy storage is like deferring the time of consumption from the time of actual generation to the hour of consumption, since power has to be consumed live. It's only through a storage system that it can be managed at a different hour, which is more like a grid management. Different applications need stored energy. Sorry, there's some screen challenge here. Yeah, sorry. Different applications which need stored energy, mostly meant for mobile applications also. These are again the second area where energy storage becomes relevant, and we need to look into that. Multiple technologies are currently available in the market, and going by the current markets and the projected markets, I'm pretty sure there is enough room for several of such technologies to coexist, provided, of course, safety and viability factors are established for the understanding of the public. Now, when it comes to energy storage, first and foremost, priority appears to be for a consumer today, at least in the mobile front, appears to be the charging time. I have dealt a few points here, which may not be in the same order relevant for all applications, but charging time definitely appears to be one of the major challenges, because whomever I discuss with, that is something, the first question I come across is what's the challenging time. Second thing, of course, people ask what is the lifetime of the battery or the cell, and what are the life cycles, and so on, so on. Third, of course, is the space requirements. What is the energy density that you're talking about, and so on. Very few people actually raise the issue of power density, which is is more relevant for immediate surge management or in the automobile front, which could probably address through hybrid systems, bringing in supercapacitors and so on. Next comes a situation where people are concerned about sensitivity to the external conditions, like what happens when the temperature soars to 40 degrees or 45 degrees or low temperatures. What are the safety challenges involving these technologies, and so on. Except for a few people who are very much aware about the industry, not many really raise the question of availability, as our good friend has asked in the earlier session. So when we really go out into the market or start speaking, not many really raise that issue. Finally, one of the major concerns that's going to come up in a big way in future is the disposal of these batteries at the end of their lifetime. Can you be recycling them, and if so, how and what is it being done? What are the parameters? What are the cost systems? What are the safety issues, etc., etc. Bharat, I'll just come briefly introduce at this stage my company. We are based out of Hyderabad and in Andhra Pradesh, south of India. Dr. Patrick Glenn is the chairman of the company, and he's also the inventor of the technology. He was the chief scientist at CSIRO in Australia, akin to our ISRO, and is presently adjunct professor of Griffith University in Brisbane. The rest of it was all this thing. Our accomplishment, we won the Kantal Award of 2018 at Stockholm, and we can offer solutions for both mobile as well as stationary applications.
Can you switch to slides? So
yeah, I'm just coming to slides, please. Yeah. One of the things that I would start away with this thing is our technology probably could be one and only one technology which will allow a charge and discharge simultaneously. This patent pending technology, we have already received the patent for Australia and USA very recently, hoping to get patents for the rest of the countries very soon, is based on physics and thermodynamics and not like the rest of the technologies, mostly which are chemistry based technologies. So this mechanism of what physics-based technology allows us to charge and discharge simultaneously, which could be very useful, at the generation points or wherever it is for stationary applications in a very big way. This is a complete green solution. I would go over it in detail in a little later. It can be for multiple applications. We use materials which are abundantly available in India as well as elsewhere. Our principal two materials are graphite and silicon, which are abundantly available. Both these materials we have been used from our childhood, like we played in sand as kids. We chewed the pencils which have graphite, which used to write. So we have lived with these two materials since our childhood. So I would say that yes, our technology or the component is absolutely safe and 100% green. Our technology also, when it comes to the duration of the long time, I would say it has got a very long life cycles, because our charge or discharge or whatever we call about, the energy is stored in phase change materials. What we do is we take electricity from any form, either DC or AC from any source, let it be from the grid directly or from the generation from solar, wind, or whatever it could be. We have heating elements which draw the electricity, convert into heat and melt the silicon, which has a 1414 degrees centigrade melting point. And we take the temperatures right up to 1470 degrees when energy is stored in the form of heat. This particular silicon is housed in a sintered graphite crucible, which is also thermally conductive. And the whole thing is insulated in such a way that outside the chamber, the temperature is as good as ambient temperature, where you could actually touch, sit, or you can be next to your drawing room or anywhere. There's no problem at all. The process that I was explaining, I just put it in a small slide. The image one, electricity from any source is taken and we have heating elements. Heat is transferred from these elements to the phase change materials, which is silicon for us, which melts at 1414 degrees centigrade. And stored energy is retrieved using heat engines or Stirling engines and reconverted back into electricity. When I talk about the longevity of life of this particular product, I would like to explain, keeping this particular image on the backdrop. Imagine boiling a liter of water in a container which is completely sealed. At 100+ degrees, the whole water changes its phase from liquid to the gaseous form. Of course, the space required for water in the form of gaseous form is much higher, but let's not get into that aspect. Supposing you leave the water alone for about 5 minutes. After that, separating it from the source of the heat, the temperature would drop to less than 100, and naturally the entire and the gaseous form of water, which is steam, becomes water again. If there were no leakage, you repeat this experiment a million times, your water 1 liter will always remain 1 liter. So similarly here, we are talking about melting silicon and solidifying it by extracting heat. So you do it any number of times, the silicon will remain always the silicon, and there's no challenge with the graphite, sintered graphite also, which are both are very long lasting. So I would say the core battery is absolutely good for any number of years without any challenges. Of course, we do have other equipment which they need to pump the power inside or take the power outside of this. So these do have certain lifetime challenges, could be for 10 years or 15 years or 20 years. But from our calculations, they are not major challenges in terms of maintenance or in terms of replacement costs. They will be absolutely negligible when it comes to the whole solution as such. Coming to the technology which I've just mentioned, this is basically a physics-based technology where energy is stored in phase change materials. There is no deterioration in the quality or the quantity of the materials used during the process of charging or discharging, which will allow it a very, very long life. At the current state, we have a 650 watts per kilogram energy density. So we would probably be able to store about 20 megawatt hours in a 40-foot container, which is totally mobile. Either for you could just put it on a truck and just move it from one point to one point. This technology is also absolutely insensitive to the external temperatures. With 1400 plus degrees sitting inside the battery, even if you put it in Rajasthan or any desert area where the temperatures could shoot to 60 degrees or 50 degrees, they don't really matter at all. Hence, this technology does not require any sort of a battery management system. We also do have a battery management system, but it's more like a dashboard, which gives out the information as to what's the amount of electricity which is going inside, what is the electricity going out, what is the temperature of the material lying inside, and so on, which will allow us to calculate how much of electricity is actually being stored or being discharged or whatever it is. The storage system, either while charging or discharging, does not lead to any pressure buildups, and hence there is no chance of any explosion. We do not have oxygen inside the cell. What we have is an inert atmosphere with nitrogen being pumped inside. So there is no question of any fire also catching. That way, with no chance of any catching of a fire or no chance of any explosions, this technology we can say is 100% safe. Unlike the chemistry technologies, which have certain challenges. I don't see they are major constraints because even if you come into automobile segment, we have been using ICU engines which use petrol and diesel, and we have seen so many accidents where the fuel tank catches fire and the vehicle has gone up into fire. But still, for several decades, we have been using this without any challenges. So other technologies which have such challenges also will be there without any of major. This may not be a major concern going forward. And as Mr. Sen was saying, in a matter of few years, I'm sure methods or new technologies would come in to eliminate such safety challenges from even those technologies. As I have already said, this technology allows you to charge and discharge simultaneously because the heating of the elements, which is the source of which is taken from the input source, is independent to the discharge source, which is drawn by the heat engines or the Stirling engines for reconverting the heat into electricity. So you can keep on using it 24/7 while charging the cell whenever the electricity is available, and use it 24/7. So there would not be any challenges on that issue. At the current stage, our technology, we have a pure electrical efficiency of 60%. Which I know we are slightly lower compared to any of the industry standards available today. But if somebody were to use the balance heat, which could go waste for either water heating applications or absorption chilling, the round trip efficiency could be as high as 94%. But I'm sure within a matter of another 1.5 to 2 years, we would be cracking into this, better mechanisms where the efficiency can go up to 85 to 86%. Which the theory does allow. We have some comparisons of various technologies, but I would not dwell on that further because Mr. Sain has extensively discussed it, so we don't need to repeat on that. Um, I would probably look into some of the solutions that can come in. Um, since it's good for 24/7 power and it can allow charge discharge simultaneously, this could be one of the most reliable baseload support solution that is available. It could be one of the best for the behind the meter applications. Now coming into the telecom tower segment, which is absolutely a large segment, which is looking for solutions across because of the location challenges and so on. If power is being made available from some local generation point, like solar and wind solution or something created at a local place. I'm talking about remote locations, not necessarily within the city. We could create a backup 24/7 or even a longer period, whatever as the requirements for the towers, and we can support them without any challenges. One of the major interests that we have been getting in the recent times is from the IT industry, more importantly the data centers, which require huge amount of electricity for running, keeping the system cool or whatever it is. So this is one area which can go in a big way. The same systems can also go for any applications in any commercial or industrial applications. That would not be a problem at all. Going into the mobile areas, currently with the physical dimensions of the cell that we have, we probably can get into buses and trucks. Probably we can get into trains, but we will not be able to fit into the smaller ones like cars or a three-wheeler or a two-wheeler. The space, physical dimensions and space available in those vehicles would not be sufficient enough for us to place the batteries at this stage. But given the higher energy density that we offer, we could probably run a bus to about 800 kilometers plus with one single charge. There's no big rocket science involved with our technology here. It is just that for the volume and the weight that is permissible in a given bus or whatever it is, we can offer almost 4.5 to 5 times greater volume of electricity to be stored. So because of the higher energy density compared to lithium and other technologies, so that will allow you a greater mileage. So we do not play any role in the efficiency of the motors or the powertrain or whatever it is. So this is what it is. One of the major, I would say probably is in the disaster management system. Suddenly some floods or earthquakes or cyclones or whatever it is coming, and the standard lines are all disrupted and power is not, power arriving into the particular location has been disconnected and so on, whatever be the problems. We could rush through on a 40-foot container, 20 megawatts, no matter of depending on where exactly this containerized storage systems are located, and move to the specific location and try to address the requirements there and bring in some relief before the rest of the systems are restored and they can be taken care of. Now, what probably could be the sizes that can give? The one that we have currently worked for and tested for more than 5,000-6,000 hours is a 400 kilowatt hour cell, which can give out an electricity of 6 kilowatt to 12 kilowatt hour based on requirement. So we can just physically scale up the sizes to take it to much higher level, where it can be even like a single container up to 20 megawatts, where you can talk about giving 1 megawatt or more based on the customer requirements. This can be completely customized, based on specific requirements there. Now, this is one of the pictures that I thought I should share with you. We launched this product about 3 years back in Andhra Pradesh when the earlier Chief Minister tenure, Mr. Chandrababu Naidu was there. we showcased the whole technology where Mr. Tripathi, then International Solar Alliance Director General, was also present and witness to the whole thing there. This image is our winning Kantal Award at Stockholm in 2018. Thereafter, some challenges came with what you call things beyond our control. So the project slowed down for different reasons, and we got stuck with certain changes happening in different states. And we are now relocating ourselves into Hyderabad from the earlier location, what we thought was going to Visakhapatnam. And I'm sure maybe in about next 1 year's time, we should be into commercial production. This is the current thing. So with this, I would come to an end this thing. But before I close, I would like to tell one thing. All the products that go into this particular technology, the solution, which is graphite and silicon, can be used any number of times once the battery's effective life is over, or if you want to discard it for whatever reasons. The insulation materials that have been used are packed into different, so sachets sort of things, one layer, and it's like a fur, bed sort of a thing. They could also be used any number of times and can be recycled without any challenge. The rest of it is a steel container, which is an external chamber. The rest of all some electronics and control panels and so on, mostly steel, so they can also be recycled. So I would say 100% of the materials are definitely good for reuse at any given time. And more importantly, today I can confidently say almost entire materials required for this particular thing can be 100% sourced from India. Let it be the basic graphite. I should thank Graphite India for their support for this. We have been procuring the material from them. Silicon processed has to be there. We are getting it. There's no problem. The rest of the things are very much available in India. The engines that we thought we had to import are now we're going to make them ourselves in India without any challenge. So I would say this is 100% made in India and 100% made for India. Thank you very much. If any of you have any questions, most welcome on that.
Well, thank you. Do we have any questions from the participants?
Yeah, I have one question.
Yeah, please, Mr.
How Stirling engine, one thing is that I understand efficiency is pretty low of Stirling engine.